Oops. Okay. Global config mode. Let's go to interface serial 00 first, and let's finish up that connection. IP address, where are we at? 172.16.0.66. Subnet Mask 255, 255, 255, 252. No shut. And we're done with that interface. And then the fast Ethernet interface, 00. IP address 172.16.0.33. 255, 224 is what we're using, yes. And a no shut there, we'll bring that interface online. And good. Save our config there. And we should be good to go with the addressing. As I mentioned before, I've already configured the PCs, so we can bring those online to do some ping tests. I have a PC1 online, and if everything's configured correctly, we should be able to ping from PC1 to the fast Ethernet 00 interface of router 1. So we're going to do a ping 172. Oops, I forgot the number pad isn't working correctly with these little Linux hosts, so it's difficult. 172.16.0.1, and it's working. Excellent. Let's get fancy. Let's see if we can ping the serial interface of router 1. And that would be 65. Aha! How about that? Excellent. Okay. So we can ping just about anything on that segment. I wonder if we could ping between PC1 and PC2. I kind of spoiled it before. I mentioned that we can't. But I at least want to show that right now, even though we just set up these nice IP addresses, it's not quite working yet. Ping 172.16.0.30, what did we say? 34, because it's the second usable IP address, would be PC2. Nothing. Nothing at all. Okay. Like I said, not unexpected. Not a huge deal. So we have the addressing set up, but we don't have any static routing set up, which means that we can't reach this network from this network, and we can't reach this network from this network. So let's fix that. We go into router 1, and we want to tell it about this network over here. The way to do that is you go into global config mode, and you enter the IP route command. You have a few options here. There's actually quite a few things you can do with this command, but the one thing we want to do is we want to specify where to go from router 1 to reach the remote network, because right now it doesn't know. It only knows about the directly connected networks. So we want to first tell it about the network, and the way to do that is it's asking for a destination prefix, and that is actually the subnet address for that remote network, which is .32. That's why I noted it up there, so we can easily refer to it. 172.16.0.32. Subnet mask of 255, 255, 255, 224. Actually, I'm sorry, I usually step through this. It then asks you for the destination prefix mask, so then we provide it. And then it's asking for a bunch of stuff, but the only thing we care about is this forwarding router's address, which would be the interface, basically where to send packets to get to that network. Now, router 1 can communicate with router 2 because they can ping each other. So, and actually, like I have not tested that, so let's do that now. Let's make sure that happens. Ping 172.16.0.66. Okay, so router 1 can ping router 2. So basically, since 66 represents the serial interface of router 2, we can send packets from router 1 to this IP address. And once they're there, since they'll be on router 2, they'll be able to reach this network just fine, because router 2 is connected to that network. So that's a perfect next hop address to use. So we're going to have to actually redo our IP route command. Sorry about that. IP route 172.16.0.32. 285, 285, 285, 224. Sorry. And then it's asking for the forwarding router's address, so we add the serial 00 IP address of router 2, which is 172.16.0.66. Enter. And that's it. To confirm, we can go out to privilege mode and run show IP route. And we have our two directly connected networks as expected. It's letting us know that it has those two networks, the 00/27 and the 064/30, with fast Ethernet 00 and serial 00 respectively. But we also have the static route, denoted by the S over here. I think it's up here, yeah, S for static. So we also have that route, and it's letting us know that this remote network here, which we just entered, is available by sending packets to 0.66. It's letting us know that to reach that network from router 1, which is what we're on right now, we have to send packets to this IP address. And it's already configured to do that because we configured static routing. We're going to go back into global config mode on router 2 and configure static routing there so we can actually make this thing work. So if you remember from router 1, we need to configure the remote subnet number, which is 172.16.00. The subnet mask is the same. And we need a next hop IP address. From the perspective of router 2, that's going to be the serial interface on router 1 because that's where packets should be sent when they are at router 2 to get to this network. So we need the IP address of that serial interface, which is 172.16.065. 65. Enter. Okay. Exit. Save. And let's do a show IP route, and we have both of our directly connected networks and one static route, just as we saw on router 1. Let's try pinging again. Oh, we actually left the ping command running, and we are working. So, yeah, I forgot that I was running Linux. So yeah, 64 bytes from 172.16.034, and that is the IP address of PC2. So we are successfully pinging from PC1 to PC2. And that's because we've told router 1 about this remote network, and we've told router 2 about this remote network. So that means packets can fly from here to here, and also from here to here. So we've configured static routing. So we have done objective 1, and we've done objective 2. Let's see about objective 3. One default static route should be created to route all remaining traffic to router 2. So what that's asking for is it's asking for one static route that catches all other packets. One of the rules of thumb with routing is in the routing table, packets will go to the most specific route. Typically, you're going to look at you'll have routes with varying subnet masks. Usually, if a packet, let's say a packet matches multiple routes, and they all have varying subnet mask, these routes, the route with the most restrictive, and that is with more network bits, will be selected. The higher subnet mask, for instance, that is going to be the route that is selected. So, if, for instance, a packet's destination doesn't fall into one of those routes, it is usually discarded unless you have a route that specifies, hey, I'm a really wide open route that's supposed to match anything. So if you don't match anything more specifically, you should use me, and that at least allows packets to get to where you need them to go. And we do that using a default static route. And there are many ways to do this. You can use certain keywords that set default gateways for this. But since we're in the parlance of static routing, there is a way to do that using the commands that we just experienced. So back to our topology. We don't need to issue any commands on R2 because the requirement states that the remaining traffic should be sent to R2. So if the traffic is already on R2, we don't need to enter any special commands to do that. We would need to if there was another connection here to forward all internet traffic out. And actually, we could probably go into that and just for demonstration's sake. Actually, what I'm going to do is I'm going to create a loopback address or a loopback interface, loop 1, and I'm going to say IP address. Let's say 1111 255 255 255 252. No shut, exit. And basically what that's going to do is it's going to provide us with a fake interface that represents the T1 line that I referenced earlier. Let's say router 2 is connected to the internet using a T1 line, and this interface here would represent that. So that's fine. And as a result, we're going to need to set a static route from router 1 to router 2. But before we do that, we want to tell router 2 to forward all traffic that doesn't have a match out this internet connection. The way to do that is the IP route command as before, IP route. And if you look, we're looking for a destination prefix, which if you remember is the network address of the remote network that we're trying to get to. We don't really know what it is, so we actually place just 4 zeros. And that represents anything. It's basically saying, hey, whatever it is, this is a very non-restrictive route, so it's going to be selected last. But if a packet doesn't match any other routes, this will catch it. For a subnet mask, we actually want to put zeros as well, which tells us that basically we don't care about any of these digits, which is why we were able to put zeros. Technically, you could have put anything here, and as long as you put zeros in your subnet mask, then it's going to be the same result. This is how it will be placed in the routing table anyway. We do, however, need to configure a next hop IP address. Now, for the sake of exploring the theoretical, I have placed the loopback address here in a network that is represented by a point-to-point network here, 1111, and then the other address would be 1112. That address would typically belong to a service provider. But we actually don't have to provide a next hop address. We can provide an interface to forward things out. And we notice one of the arguments that we can use is loopback. So we specify loop 1. And that's telling us whenever you receive a packet that doesn't match anything else, forward it out loop 1. And since this represents our internet connection, basically what we've done here is we've told router 2, hey, whenever you receive traffic you don't know about, just send it to the internet. That's a pretty typical configuration. We're going to exit out and we're going to say write, and we are done with router 2. Finally, we need to configure router 1 to forward packets to router 2 to do the same thing. Here, we go into global config mode, IP route 0000, 0000, and then the next hop IP address, which we can provide, which is this .66 here. 172.16.0.66. Enter. And let's do a show IP route to verify our changes. We have our static route that we created before, which is the 172.16.0.32, which lets us know about the LAN segment off of router 2. But we also have this static route here. You'll notice there's a star next to it. The iOS has actually detected that we used that 0000/0 subnet, which indicates anything, and it has determined that that is a default route. It's basically letting us know that this is what will be selected if all else fails. And it will be, because all of these subnet masks are far more restrictive than 0. In fact, they're close. The 30 is the most restrictive subnet mask you'll ever get, and then 27 and 27. So it looks like our changes are configured correctly, and we have our default route. So what you'll see is whenever you forward traffic to the internet on PC1, it'll be sent to router 2. And it'll be sent to the T1 line, which is the loopback interface we configured before. Alrighty. So we've configured the lab to do to use that address block as efficiently as possible, keeping in mind the requirement of 18 addresses. So that will need that called upon your subnet knowledge. So that was good practice. And we explored static routing so that all networks could reach other networks. And we finally created that default static route to route all remaining traffic to router 2, which would be the configuration you would want to do in the event you wanted to configure the internet connection, things like that. I hope this has been informative, and thanks for viewing.